Okay, so this lesson is on modeling with quadratic functions. So when you are doing modeling of any kind, you're going to be using your graphing calculator. Remember, when we did this with linear modeling, you used your graphing calculator to put the points into the stat plot and run linear regression to get the equation of the line. And you're going to do something similar here, except for quadratics you use what is called quadratic regression. Now, the only difference between this and the other one, other than quadratic regression and linear regression, is you have to have at least 3 points in order to use it. So a lot of times when you are doing these types of problems, you'll see only 2 points given to you. So you have to find the third point. What you have to recognize, and I'm just going to sort of zoom in here into this. What you have to recognize with this is parabolas are symmetrical. Parabolas are symmetrical, and so whenever you have a point on this side, you will have a matching point on this side. Since this is 186, you go over here, you're going to have another point right here at 5 and at the same height of 86. So 5, 86. It's important that we have that third point. Quadratic regression will not work unless you have at least 3 points. So a couple of these questions can be answered probably just looking at the graph. A lot of times it's that simple. So in A it says, what's the maximum height of the flare? Well, I don't need to run regression models to see this. I can just use this right here. The maximum height would be right here of 150. So 150, I think it's feet. Yeah. Let me zoom back out so you can see what I'm writing there. Okay. The other question, at what time does the flare reach its maximum height? So the time that it reaches the maximum height would be the x value. So it reaches the maximum height after 3 seconds. And finally, approximately how far will the flare travel? You can go over here to where it hits the ground. Looks like it's about 6 seconds. Now, in this particular problem, we didn't need to run quadratic regression because all of the points that they're asking for can be interpreted with the graph itself. Now, most of the time that's not going to be the case. You're going to have to use quadratic regression because it's going to ask for either the function or the equation, and then ask you to predict different information. So when we look at the second problem here, you have a new ride, a new roller coaster ride, and so you get sort of a visual of what that ride looks like. It is in the shape of a parabola. We do need the third point, but this one's a little bit more difficult because the point is actually the vertex. Let me zoom in here so you can. The vertex is at the top, so our axis of symmetry runs like right down the y-axis. So to match the other point, you sort of have to go into negative territory over here. Since you have 1 and 164, you're going to have another point over here that'll match it at -1, 164. I don't know if you can see that, but -1 and 164 will be my third point. Okay, zoom back out. Okay, so the second part of this says, interpret the meaning of the vertex. You've seen a lot of sort of interpretation type of questions. But seen as though that this is a new ride on a roller coaster, and we sort of get a visual of what it looks like, the vertex can probably be interpreted that that's the highest point. That's the highest point of the ride. So you can say highest point. Wow, that's terrible. Highest point of ride. Now you see here on B, it says write the function that models the height over time. So here we're actually going to need to run quadratic regression. So what we need to do is you're going to do the same thing you did for linear regression. I'm going to get out my graphing calculator here. Okay, put this sort of side by side. Hopefully you can see it with this light on. Let's see if I can shut this up. I know it's a little dark, so we can brighten it up a little bit. That's not going to work. So we're going to run, go back to our stat plot and go to edit. Let's see if I can pull this out of the glare. Hopefully that helps. So we're going to go to stat just like we did for linear regression, and we're going to put in our 3 points. You have 1 and 164. You have 0 and 180. And you have -1 and 164. So it's important that you have 3 points. This won't work without it. So, and then now, instead of going to go to stat and going to calc and going to linear regression, we're going to go to one right below that and go to quadratic regression. We hit enter and enter again, and there is our A, our B, and our C of the quadratic function. So what this is telling us is, I slide this over here, it's really hard to see, sorry. If I can brighten this up at all. No, it's a little hard to see. But basically, our function is going to be y equals, and then you have -16 for my a, so -16x squared. 0 is my b, so I don't actually have to put the b term there, and then plus 180. And that's it. That's going to be our function. So in moving forward now, we're going to be using that function. So that would be the equation of the path of that ride. C says to use your equation to estimate the height after 2 seconds. So we're going to use the function to estimate how high it would be at 2 seconds. Now you can probably go over here and make some sort of estimation as to what it is, but we can use the function to get the exact height after 2 seconds. All we do is simply put 2 in for x, just like that. Do our exponents first. 2 squared is 4. 4 times -16 is -64 plus 180. -64 plus 180 is, I believe, 116 feet. So that's quadratic modeling. Sometimes they give you the graph and you're going to have to find the equation. So there's a couple examples here. So we're going to go over all 3. One example, they give you the graph. You have to plug it into StatPlot and find the equation and use it. The other type, another type is if they give you the equation already. Now this is the easiest kind because you don't actually have to find the equation, you just have to use it. This is where Desmos is going to come in. Okay, Desmos comes in to the ability here to use this function to really easily figure out the information that you need. So the path of a basketball thrown can be modeled by the function y equals -0.02x squared plus x plus 6.36. Y is the height of the ball and x is the horizontal distance. How high did the ball travel? You certainly could do this in a graphing calculator, plugging it into your y equals and then graphing it and finding the vertex and finding the y-intercept. But I'll tell you right now, it is way easier to use Desmos. So, and since we can use Desmos in this class, I want to take advantage of the fact. So I'm going to place this so we can see the equation sort of at the top there. And I'm going to place this here so we can see Desmos. So in Desmos, we're going to type in the function. So y equals negative 0.02 x squared plus x and plus 6.36. So it's in there. I know it's really hard to see. Maybe we can make that a little bit better. Yeah, I'm going to need to zoom out. So just to show you, the equation is in there, so we can see it like this. So it makes it real easy. Let's turn on projector mode so you can see it better. Real easy to figure out that that's the path of the ball. That's the path of the basketball. So if I want to know the highest point that it reaches, I just tap on the vertex. So it looks like the highest point that it reaches is 18.86 feet. I can also figure out at the height that it was thrown at by looking at the y-intercept. 6.36. Well, if you already know this, your C is always your y-intercept, so you can see how that these match 6.36 and 6.36 in the equation. I can also figure out where it lands, or at least how long it takes to land, and that's over there at 55.708 seconds. I know it doesn't seem realistic, like maybe they're playing basketball on the moon or something like that, because it's in the air for 55 seconds. But you get the point. Okay, that's the highest it was at. This is when it landed. That's the height from which it was thrown at. And you can actually find any value on here. You'll see that the data changes as you hold on to the graph there. So that's it. So let's answer some questions. So here it is. Let me turn back up the brightness so we can see this. So it looks like there you go. Here's our equation. It said how high did the basketball travel? Well, we got 18.86, so 18.86 feet. How high was it released from? Well, that's just your y-intercept here. It's right there. It's 6.36 feet. So, you can go ahead and practice with B. If you want to, I'll put the answers up real quick. But basically, if you want to pause the video, you can, and do B and see if you can get the answers. So go ahead and pause the video and check your answers. Okay, so it looks like how long was the shot put in the air? It looks like that it was in the air for 77.72 seconds. Again, I guess we're on the moon or we're in outer space or something, but you get the point. At what time does the shot put reach its maximum height? Well, that's 35 seconds. And you can get that from Desmos. The last example, and we're just going to do one of these, and you can try the other one for practice. But the last one of these is when they give you a data table and you have to figure out the equation and all that stuff. It's similar to the first one where they gave you the graph, in that you have to put all these points into your stat plot into your graphing calculator. So what we're going to do is we're going to put this in all these points into our graphing calculator by going to stat plot and editing it and putting them on there. So my x values are 0, 1, 2, 3, 4. my y values are 400, 384, 336, 256, and 144. So I know it's hard to see on my end, but you can see that all of the pieces are in there. You can see all of the data points are in there, and so we're going to go to Stat, go to Calc, and go to Quadratic Regression, and hit Enter. And again, I know it's hard to see, but it gives you the equation. You should have negative 16, and then 0, and then 400 for your points. So what we're going to do, I'm going to set this aside, is I'm going to write my equation. My quadratic formula, or quadratic equation here is y equals negative 16 x squared. There is no b term, and plus 400. So that'll serve as my function. And now I can use that function to plug into Desmos to figure out the rest of this. So now I'm going to put my calculator away, go over here to Desmos, slide that out, slide this in, and I'm going to plug that equation in there. So y equals negative 16x squared plus 400. Okay, now we can pinch the y-axis like this to make it so it's not so steep. You can see as I'm scrunching it down. We can even stretch out the y-axis or the x-axis. So you get a path of this a wrench that's been dropped from a construction site here over time. So it says at what height was the wrench dropped? Well, we know that is just the y-intercept. So that's 400, but we can verify it there. It's dropped from 400 feet. And it says, how long did it take the wrench to hit the ground? We just tap when it hit the ground, and it's 5 seconds. Finally, something a little bit more realistic. It's not on the moon, a construction site on the moon. But basically, there are your answers. Okay. It was dropped from 400 feet, and it took 5 seconds to hit the ground. So go ahead and try B on your own, and go ahead and try B, putting all those points into your stat plot, and then coming back, play the video when you are ready to see the answers. I'm going to plug these in real quick so I can give you the answers. Okay, so here we are. The equation that you should have got, it does not ask you to answer what the equation is, but you do need it, so I'm just going to sort of write it over here. So y equals negative 100x squared plus 2000x minus 1000. And then that ends up going into Desmos. Y equals negative 100x squared plus 2000x minus 1000. Okay. And so if we bring everything into view into Desmos, it says what price would the venue maximize its profit? Basically, this is as real world as it gets. A lot of times companies will look at what the ticket price is, how much profit they're making. You would think that the higher the price point, that they would make the most profit. The problem is the higher the price, the less people want to buy them. So they have to find that perfect sort of middle ground when doing ticket prices that people still want to buy it and they're still making enough money. So that's that maximum profit. And you can do that by just clicking on the vertex. If you're in Desmos, you can click on the vertex, and it looks like the perfect price point to maximize their profit is $10 per ticket. Okay. And at that price point, theoretically, how much profit would they make? And that's just the Y value. They'd make $9,000. That's quadratic modeling, and that finishes up Unit 3. So go ahead and do the practice. There's practicing big ideas there, and then when you're ready, you can look at the review and the test for Unit 3. Thank you.